I'm Shunsuke Tsukada from Tohoku University. The poster title is Metadata Management for Large-Scale Hybrid Memory Architectures. First, I will talk about the background. Today, a main memory system requires a higher bandwidth and a larger capacity than before because of an increasing in HPC and big data applications. To realize a higher bandwidth and a large capacity, and a hybrid memory architecture that is contained of a near memory and a far memory is anticipated. A near memory is higher bandwidth but small capacity. On the other hand, a far memory is low bandwidth but large capacity. For the data management in these memories, a metadata that indicates where data are mapped in the NM or the FM is necessary. Generally, the conventional HMS stores metadata in a metadata memory array separate from the NM or the FM. Here, the metadata memory array is called MMA. In such an organization of HMS, it is required to access in two steps. First step is to access the MMA for referencing a metadata. Second step is to access the FM or the NM for referencing a block data. Next, I will talk about a problem. In the future, as HMS are expected to have a larger capacity, more metadata will be needed. This graph shows that if an HMA has almost 600 GB, it will be required to have almost 1 GB MMA. By considering a significant increase in the capacity for metadata on an HMA, it is not practical to store all of them in a memory controller on a processor chip. To solve the problem, it is needed to reduce the size of MMA. To reduce the size of MMA, this poster supposes in-memory metadata management, in which a control mechanism of HMS stores metadata in the NM and other FM. Moreover, only metadata that will be used in the future are stored on a small on-chip MMA. However, when the target metadata is not in the on-chip MMA, which means an MMA miss is occurred, it is required to additionally access to the NM or the FM for referencing metadata and be considered to cause performance degradation. To mitigate the performance degradation, it is needed to predict the necessary metadata for storing them in the MMA in advance. Towards such an HMA, this poster analyzes access patterns to the metadata to find a way to predict the metadata used in the future. The experimental results show some useful insights. First, we define a metric called an address difference here. The address difference is obtained by subtracting previously accessed address from currently accessed address. Please look at this graph. The horizontal axis represents time, and the vertical axis represents address difference. The address between currently accessed data and the next accessed data is within a certain range. By using the past access patterns, it is possible to predict the future access range. Next, please look at this graph. The horizontal axis represents block address, and the vertical axis represents access counts. The number of accesses to a metadata and that to another metadata tend to be the same if their addresses are near. By using the characteristics, it is possible to predict the number of accesses. In this research poster, a conclusion is that the experimental results show the behavior of metadata access to predict metadata with metadata caching. Future work is to design the metadata prediction mechanism by using the metric and implement it. If you are interested, you can read more details in our research poster. Also, if you have any questions or comments, please contact me by email. Thank you.